Okay, so obviously we're going to need some resources to make the game. So we're going to start with the 2D game. And I thought I would go ahead and show how I do the test images. So not a final version, just something quick to test with, just some tiled things. So I usually start in Microsoft Paint because that makes it easy. We can draw a shape with these various fill patterns already built in. Very quick and easy to do it this way. So I'm just going to pick a couple colors, maybe something brownish here, dark brown. Then I set the fill to like a crown fill, and I'll fill in a little box. Whoops, this one's supposed to be brown. Color 2 set to brown. And I'll stick that on there, and maybe do a couple layers of these. So maybe a lighter brown on top of it. Get something dirt looking, and then throw something green on top to look like plants. So definitely not a final image, just maybe not that. Let's take that and maybe do a pencil fill. There we go. So a little tile, but in order to be a tile, we need the left and right sides to line up, which they don't just with the generic pattern, but if we hit Control A to select everything, Control C to copy, then extend this over and paste that in there, we can flip the copy over horizontally and line that back up. And now we have something that the left and right side should align with. And then we can do the same thing. So Control A, Control C to copy, a little more space, paste that in there, and then flip that vertical and slide it into position there. That'll work. And now we know we have something that the left and right and the top and bottom sides all line up on. So definitely not a final version, but something that will line up for tiles and give us a background for the character to work with. So for our 2D game, two 2D games, a bunch of tiles for a top-down view, and then kind of stretch those out into long platforms for a quick platform test. So I'm going to save that. That's the only part I use Microsoft Paint for. We go in Documents, Basic Control Unit, PyGame Test, which I don't have anything in here yet. Test one will be a top down. And I'll just save this image here and call it ground. And I just use Microsoft Paint to very quickly get those textures and flippings lined up. Then after that, I do most of the stuff in this software, Helios Paint. It's an open source one, and I was able to find the source code. It's a lot like GIMP. All the features that you would have in GIMP, if you would prefer to use that. Just maybe the buttons are in a slightly different place, and when I can, I like to download the source code for things and then kind of play around with them. But I'm back to the original version of that here now. So first thing I'm going to do is, I don't bother saving that. I'm going to open that basically tile I've just created and resize it here. So with nothing really selected, make sure nothing's really selected, and then go to the size option, and I guess 64 by 64 sounds like a good size of tile. And we know the left and right and top and bottom sides line up on that. So that'll give us a tile. And we can do a new one, maybe 64 wide, 128 tall for a character. And that'll work for both the platform and overhead top-down view. Not final images, just some images to test with. And what I like to do for quick images is I'll use this freehand selection tool, which is really a bunch of polygons set on a timer, so it's constantly tracking where where the mouse is. And then we can just kind of draw some shapes here. So I'll come over here somewhere and find something that looks like a flesh color and start with a little head for the character. Neck, the back of the head, come around, get it on the nose, the chin, the other part of the neck. There we go. And what I usually do is click on another tool just to make sure that's finished and then come back to it. Maybe put this character in a red t-shirt. Drag around here, come like this. Not the best one, but that'll work. This is just a test image. Obviously, final versions would be, I'll go back to the skin color. Final versions would probably be a little more detailed, a whole lot more detailed. Give him an arm, and maybe some blue jeans. But we just need some quick test images. That way we're not moving squares around the thing. And whoops. And obviously, eventually it would be animated. But over the years, I've found it's a good idea to put off the animations for a little while. Whoops. Undo that. I gotta redo the blue jeans. I forgot to finish the tool. So, redo. There's the arm. And I'll draw some blue jeans here. Down for one leg. Down for the other leg. Something like that. That'll work. And just a still image to test with. As like I was starting to say, over the years I found that it can be a good idea to put off the animations for a little while, because sometimes bugs will hide behind the animations and you won't notice it, and then they'll show up as a much bigger deal later. So just some sort of still image to represent a character. Select all that and move him over about centered in that area. There we go. I guess I could stretch it to fill the 64 by 128 size. Go here and stretch that until it kind of fills that up nicely. Maybe move it. I'll just center it. That's fine. That'll work for a testing one, and then we can get better images on later. And this will be player. And this one handles all the background images. Microsoft Paint doesn't do that. That's why I like to do it in these. But that gives us two quick images to work with to get our game started. So if I come over here, where's that? So a couple quick images to work with. So let's look at just getting something started in PyGame now. So now that we have a couple resources, let's look at the basics of PyGame to get those showing on the screen, and then we'll get to the controller stuff. So I'm just going to do this in Notepad. So obviously we need that module we just installed. So we need to import PyGame. I'll save this in the folder with those images. That way we don't have to, everything's in one folder, because these are going to be small tests. There won't be a lot here. So I'm just going here and test one top down. I guess I'll call this test1.py. Gives us something to use. And then to initialize, the first thing we have to do is initialize it. PyGame.init. That initializes everything about PyGame. And then we'll need some stuff just about the engine. Basically the speed it's going to run at and our screen. So we'll need a clock object, which I'll call pygame.time.clock. We can call this built-in method to get that. And then our screen size has to be passed in as a tuple. One thing about the PyGame engine is a whole lot of the values we pass in need to be passed in as tuples. So I'll go ahead and set it up this way. Call it screen size and create a tuple, which is a non-dynamic list, a list that we cannot change, basically. And I'll use 768 by 512. I checked those numbers right beforehand. Those are both divisible by 64, and our tiles were 64 by 64, so they'll fit evenly on that size. Then we need a screen. Screen. Just making a reference to refer to that. PyGame.display.set mode, and then I'll pass in the screen size. And I guess I'll give it some sort of caption. PyGame.display.set underscore caption. Basic control unit test 1. Just saying what we're doing here. And that'll be enough to get the first thing going. So now we need our main loop, which is an infinite loop. So we could just put while true, but it's better, and then do our looping stuff. But it's a little bit better form to have a variable so that we can change it, because we will want to exit eventually. So I'm just going to create a Boolean variable called plain and set that to true. So just while plain is really the same thing as saying while true, only I can go ahead and change that, which might as well do that. So one thing we'll want in every game is we'll need some events. So for each event, remember for loops in Python are actually for each events. So for each event in pygame.event.get, and you probably already noticed Pygame is going to be typed a lot. So the other type of import might be nice here. Since this is the first time it's shown up in the tutorial, I decided to type it this way to get a better sense of how much of what we're typing is included in that engine itself. So we're just going to walk through all the events that the engine knows about in a for loop, so one at a time. And if event.type equals pygame.quit, and that needs to be all capital letters. It is a constant in there. Then we'll set plain equal to false. So there's our exit condition, and then all of our events will just go kind of inside of this loop here. For these simple tests, I'm going to avoid doing object-oriented stuff. I'm just going to do it all in methods and just straightforward and do the implied object, the thing where every Python script is a namespace collection of objects. So technically this is an object. So it is object still. I'm just avoiding the class notation. And I'm just going to do it with functions and basically treat the whole thing as the main method and then throw some functions in there. So that's our exit condition. So I guess now we just need to kind of show our thing. So after that loop, I'll leave a little bit of space because the last thing we want to do each time is we have pygame.display.flip is the method that will update our screen. That's constantly going to update. And then we need to set the speed of the clock. How often is it going to update? Which this can change. It can go up and down, but I'm just going to go with 60 frames per second to start with. So this is the basic just to open the Pygame window. So we initialize it, get a reference to our clock, the speed, set up the display. The caption's kind of optional, but it always bothers me having a window open without some sort of label on it. So I always take that option. And then just in an infinite loop, well, semi-infinite, because eventually we will click that little X button, which is a quit event. The little close thing once our window opens, that is the pygame.quit event. So at that point, we'll change this to false and shut down gracefully. And our graceful shutdown is after that infinite loop, we can just call PyGame.quit as a method. So all lowercase. So notice that our type is referring to a constant, so it's all uppercase. But when we actually need the function, it's all lowercase and parentheses to say it's function. So I'm save that, and this is the bare minimum to open a PyGame window. So let's see. I was doing the typing in Notepad, so I'm going to just run this in PowerShell. So where am I at? Copy this, just to make this a little easier. Set location, which if you weren't familiar with it in PowerShell, the command prompt instructions do work. So you could do CD for change directory the old way, but one of the updates was spelling things out, so then we don't have to memorize a bunch of abbreviations. So set location or the old command prompt instructions, if you're familiar with those, do work in PowerShell. PowerShell added things to them, it didn't take anything away. So now we can run that. So Python run test1.py. We get that, and there's our little game window. And like I said, the quit event type is when we hit the close window. So we'll close that, and it shuts down. So now that we know our window works, we can throw a couple images on there. And to keep it simple here, I'm just going to do these as regular functions. So yeah, to keep it a little simpler, it's not too complicated of a thing, but as it gets bigger, it would definitely be it becomes a better and better idea to use classes. But for testing the controller, just some simple things will work. So we have those images, so I'm going to bring in the player sprite, and to bring those in, once again, we'll call our module, so pygame.image.load, and we want to load, what did I call it? Player. That was a good name for it. I'm surprised I forgot what it was. The player.ping file. And for the ground sprite, same thing. Pygame.image.load and load ground.ping. And now we can just bring these in with a couple functions. So I think this will be the easiest way to do it. We'll show that player sprite at some XY coordinate that we'll pass in, and we'll pass in the XY from our main loop. So the player function, and we have, well, it's obviously object-oriented stuff here. So this screen object we created has a bunch of different methods built into it. One of them is this .blit, B-L-I-T. I'm not sure what that's an abbreviation for, but whatever blit is, that means show the sprite. So which sprite do we want to show? Well, we want to show player sprite, and we want to show it at that XY that was passed in, but we want the XY as a tuple. So the rule of thumb for PyGame is anytime you have more than one number, just go ahead and assume it needs to be passed in as a tuple. And we can do the same thing to show the ground. Ground X will be at some XY coordinates. And again, we'll call our screen object, and then .blit the ground sprite at those XY coordinates we passed in, but they need to be in a tuple. So that's the first bit of the functions for our player in the ground. That'll probably be it for the ground, because the background is just going to show in the back. And then to put them on the screen, we just ask for those methods. So player, and we need some place to start it with. I don't know, 123, 234. That's well inside the limits here, so just a couple random numbers to start with. And those the background images are tiles, so we actually need a whole lot of those. There are only 64 64 by 64 pixels. And I did pick a screen size with numbers that were divisible by 64. So we can just walk through those in nested for loops. So for pi in range 0 to 768, going across in steps of 64. Then we'll do for j in range 0 to 512, again going with a step size of 64. And just some nested for loops that should look familiar to everybody. If you've followed along this far, or know enough about Python to follow along this far, because this obviously isn't a first steps in Python tutorial. But on each pass through that nested for loop, we're going to put display that ground sprite at position ij. And then it goes in order, so the first things we put in are further in the back. So as we go down our code, the objects get closer and closer to us, or lay on top of us. So the ground was asked, we said put the ground sprite first, and then the player sprite, so the player sprite will be on top of the ground sprite. So if we save that, come back over here and run that again, it should run, but I was talking and typing. Oh, there we go. So we have our player sitting on top of that tiled background. So now we're ready to move him around, and that'll and give our controller a test. So that's the basic idea. We initialize PyGame, set up a clock, the clock for the engine, the size for the rendering. A caption on the screen is always good. I know it just bothers me to see a window without some sort of label on it. Then we do image.load for our sprites, and then just a function to call those, and then we can change these XY coordinates where they're at runtime with our controller. So that'll be the next step. But you see it. Oh yeah, and then the display.flip updates the thing, and the clock object we initialized .tick sets our frame rate. So you can see we're not locked into 60 frames per second, but that's kind of standard anymore, so I'm just going to type it in there, but we could slow that down and speed it up if we needed to when games get big. So next up, we'll add the controller object in. I'm going to close out of that, and this is probably coming on good time for the limit for the video, so that'll be in the next video. We'll start doing the controller object, which I'm actually going to do the class notation object for a controller and bring that in, and that way it can be reused over and over and over again.